Hello, today we're going to look at assignment 5 from the STEP support programme. This question is all about a tetrahedron. Now, if you haven't seen a tetrahedron before, it's a triangular base pyramid. Lots of the time you'll meet regular tetrahedra, which are ones where all of the faces are equilateral triangles. In this case, we don't have a regular tetrahedron. This question has got two parts, and it's also got some information at the top, which is sometimes called the stem. So this part at the top here is information which is then used in the rest of the question. So throughout the whole question, points O, A, B, and C are these defined points. Right, what we're going to do first is we're going to look at the first part of the question. And we're asked to find the volume of this tetrahedron. So it's probably a good idea to try and sketch it. So I'm going to do my best with this. When you are doing this, you will be able to use a ruler, so yours might be a bit neater. And I'm going to draw three axes. We know that A, B, and C are positive, which is going to help us draw the tetrahedron. It means we don't need to worry about drawing negative axes as well. So I've got some X, Y, and Z axes. I know that the point 0 is at 0, 0, 0, or the origin. We know that point A is A along here because it's got coordinates A, 0, 0. So this distance is A. We know that B is got coordinates 0, B, 0. So B is going to be this point where this is length B. And C has got coordinates 0, 0, C. So C is up here. And as I said, your diagram can be a little bit neater than mine. Okay, so this tetrahedron is what we get when we join these points up. So I'm going to attempt to draw this. Which actually doesn't look totally awful. Okay, the first part of the question is asking us to find this volume. If we think back to the first part of the question, it tells us what the volume of a tetrahedron is, so we can use that. So the volume of the tetrahedron is 1/3 times the area of the base times by the height. And very helpfully, the base is a right angle triangle. So the base looks like this, where this is length A and this is length B. So the area of the base is a half AB. So therefore the volume is 1/3 multiplied by a half AB multiplied the height C. So we get 1/6 of ABC. So that will be the answer to the first part. If you are not completely convinced by my drawing, I do have another version of the tetrahedron that I can show you. So this I have just made in GeoGebra, and this is the point A. I can move point A if I want to. Point B, which I'm trying to move, I can't move. That's because it's at its maximum moment. And point C, which I'm trying to move. Now I'm moving the whole thing. I'll move it over here. And so from this, you can see that if I look straight down on it, we can see that right angle triangle for the base. And looking on the side, we can see that that's a right angle triangle as well. So we've got sort of 3 right angle triangles for faces and then 1 awkward face. Okay, so we've done the first part. Let's think about the second part. And this says, let angle ACB equals to theta. So we're considering the triangle ABC. And if we go back to the GeoGebra file, then this is this triangle here, this wonky non-right angle triangle. So that's the one that we want to consider. So it's a good idea to sketch it out. So we've got a picture like this. This is C, this is A, this is B, and we know the angle ACB is equal to theta. Now there's a little bit of caution needed here, because normally when you have a triangle that looks like this, you would label this side C, being opposite C. This length is not C. C has already been nabbed for the tetrahedron. So if you think back to the tetrahedron that we drew earlier, C is this height here. So this length is C. This length is A. This length is B. And this is the tetrahedron that we're looking at. Well, this is the triangle that we're looking at the moment. I'm afraid my diagram is slightly less good this time than the time before. So this is the triangle that we are currently considering. That was a very wonky line. So be careful that you don't write ABC for the lengths, because that's not true. However, we can find this length AB because we've got a right angle triangle. So this length is the same as the square root of A squared plus B squared using Pythagoras' theorem. In a similar way, this length here is the square root of A squared plus C squared. And this length here, which is this one, is the square root of C squared plus B squared. So those are the lengths that we want to be using. Now, with this part of the question, we're trying to find cos theta in terms of some other values. So it might be an idea to think about the cosine rule, but you need to be a bit careful, because if you write down A squared equals B squared plus C squared minus 2BC cos A, then you might be tempted to actually leave A, B, and C in there, and A, B, and C are not actually the angles, not actually the lengths we're going to be using. So what you could do is you could just put some quote marks around it to tell yourself that you're using this formula, but the A, B, and C there are not A, B, and C in the diagram. The other thing you can do is you could change all of these to be A dashed, B dashed, C dashed, just to remind yourself that you need to write those in terms of the A, B, and C from the question. So there's quite a lot of step questions which use letters that you already know informally in a slightly different way, and you just have to be a bit careful. So applying the cosine rule to this triangle, we're going to have this angle here. So we're going to take the square of this side. So we've got A squared plus B squared. These brackets are not necessary, but I'm just going to put them in there to make it look a bit neater. So that's this length, and that equals this length squared plus this length squared. So we've got A squared plus C squared plus C squared plus B squared minus, I'm starting to run out of room, so I'm just going to shift down a bit, 2 square root of A squared plus C squared, square root of C squared plus B squared cos theta. Okay, and this is looking quite promising now, because we've got this thing here, which looks very similar to this. So hopefully this is all going to work out. So what I'm going to do is I'm going to start by cancelling some things. So I've got an A squared on both sides that cancels, and I've got a B squared on both sides that cancels. So that means if I take this to the other side, I've got 2 square root of, I can just do both of these expressions inside the same square root, as long as I multiply them. A squared plus C squared. Let's just turn those the other way around so it matches the given answer. B squared plus C squared cos theta. This side we've got 2C squared. Well, that's nice because the 2's will cancel. Therefore, we get cos theta equals C squared over the square root of A squared plus C squared, B squared plus C squared as required. So when you have questions which ask you to show that something is true, you must make sure that you show enough steps to justify your answer. You can't leave out big gaps. So probably it's a good idea not to go straight from this line to this one and just do one extra line of working. Okay, the next part is find in terms of A, B, and C the area of the triangle. Now, what I'm going to have to do is I'm going to have to get rid of some working so that I can do some more working. I'm just going to get rid of this lot. We've shown the required equation, so I still have that to refer to, which is good. Okay, so we know that the area of a triangle is, and I'm going to put it in quotation marks again because it's not A and B. So we know that the area is given by this. We don't know what sine theta is, but we do know what cos theta is. So hopefully we can work out sine theta. So using sine squared theta is 1 minus cos squared theta. We get sine squared theta is 1 minus c squared over that thing from before. Putting that all onto one, oh, that is wrong. This is actually c to the power 4 because I need to square it, which is good news because I thought I was going to have to do a whole load of work with square roots, which is going to be less than appealing. C squared, b squared plus c squared. Okay, taking everything into the same fraction, this gives me a squared plus c squared, b squared plus c squared minus c to the power 4 over a squared plus c squared, b squared plus c squared. And then I can do a little bit of cancelling because if I expand these brackets out, I'm going to get a c to the power 4, which will cancel with that c to the power 4. So this gives me a squared b squared plus a squared c squared plus c squared b squared all over this thing. Okay, so that's my expression for sine squared. So what I can do is that I can write that that means, I'm going to write it over here so that it doesn't interfere with the video in the top corner. This means I've got sine theta is equal to the square root of a squared b squared plus a squared c squared plus c squared b squared all over the square root of a squared plus c squared b squared plus c squared. Okay, so now I am going to substitute this in to find the area. At the moment, there's a little bit of me hoping that all of the algebra is going to work out nicely, because at the moment it looks like it's going to be slightly messy. So substituting into here, we have a half. Length A is this length, the square root of c squared plus b squared. B is this length. So that's the square root of a squared plus c squared. This is now looking quite nice. And sine theta is this thing. So that's the square root of a squared b squared plus a squared c squared plus c squared b squared all over the square root of a squared plus c squared, b squared plus c squared. And these things cancel with this. Oh, so we end up with a half square root of a squared b squared plus, and I'm going to write this in a slightly peculiar order, b squared c squared. So that's this one, plus c squared a squared. Now, the only reason I've written like that is then we've now got a cycle of terms A, B, C going round. It just looks slightly nicer like that, in my opinion. So this is our final answer. It's always a good idea to do a quick sanity check. So if we turned our tetrahedron around. So if instead of having C up and A across, we had A up and C across, we'd expect the area of the triangle to stay the same. So we wouldn't expect, as we rotate our tetrahedron around, the area of that triangle to change. And you can see from this expression here that this is symmetrical in A, B, and C. So if I swapped A and C over, I still get the same answer. So it's a really useful check. If your original question has some symmetry, you expect your answers to have some symmetry. So that feels like it's hopefully the correct answer. And we're going to find out when we look at the next part. Okay, moving on to the final part. We have hence show that. So I need to create some space. So we have a hence. So we're probably going to use things that we've already done in the question. So it's a good idea to just write down what it is that we've found out. I'm going to leave that thing in the square box for a second so that I can make sure that I rewrite it correctly. Okay, so what we found out so far is we know that the volume is 1/6 ABC, and we know that the area of ABC, the triangle, is equal to 1/2 square root A squared B squared plus B squared C squared plus C squared A squared. That square root should go all the way to the end. And thinking back to our tetrahedron, I've drawn it slightly exaggerated this time. That's missed a bit. Let's see if I can deal with that. That's slightly better. So this is our tetrahedron. So we're trying to find the perpendicular distance of the origin from the triangle. So if I just try and do this in a different color, we're trying to find a distance, something like this. So where this line is at right angles to this face. It's a bit hard to sort of draw a right angle to his face there. So one way we can think about this is we can think about rotating our tetrahedron so that that face ABC is now horizontal, so sort of on the floor. So I don't know if it's triangular, if it's right angled. So we've now got a picture a bit like this, and D will now be the vertical height of the tetrahedron. I'll take that out because I've already written it down again. And let's just put that in as a red line, like on the previous one before. Okay, so we've considered moving our tetrahedron around so that the triangle ABC is now flat on the ground, and D will now be the distance straight up. So thinking back to what we're told right at the start of the question, we know that the volume is equal to 1/3 times the area of the base multiplied by the height. Now in this orientation, that means it's 1/3 times the area of ABC times, and the height here is this distance D. But we also know what this volume actually is because we calculated it in part I. We know that this is equal to 1/6 ABC. It's meant to be B. So we can substitute in what we know for the area of ABC. So we get 1/3 times 1/2 times the square root of A squared B squared plus B squared C squared plus C squared A squared multiplied by D equals 1/6 ABC. 1/3 times 1/2 is equal to 1/6. So there you go. And before we do anything else, it's worthwhile just pausing for a second and thinking, the given answer that we want has got 1 over d squared on one side. So it'd sort of be a natural thing to do to separate d out on its own and divide by this. But actually, it might be better if instead of doing that, we divide by d, so that we get 1 over d on this side, and we divide by ABC. So if I do that, this is a case of going back to what we're trying to actually end up at to give us a hint on how best to rearrange this equation. So I've divided by d and I've divided by ABC. So I've now got that. The given answer wants us to find 1 over d squared. So if I square both sides, I'm also going to flip them around. I get 1 over d squared equals, this thing here becomes a squared b squared. So basically the square root just disappears. Now at the bottom we have a squared b squared c squared. Now I'm starting to run out of space a little bit, so I'm going to just get rid of that section. So this means that 1 over d squared, and I'm going to actually splat out these 3 fractions. This step wouldn't actually be necessary when you're doing the step question. It just makes it a little bit clearer when I'm explaining it. So it would be perfectly fine to go from this line here straight to the answer. But if we're going to separate up these fractions, I get a squared b squared over a squared b squared c squared plus b squared c squared over a squared b squared c squared plus c squared a squared over a squared b squared c squared. We have lots of cancelling going on. So this gives me 1 over d squared is equal to 1 over c squared plus 1 over a squared plus 1 over b squared, which is the same as what we were trying to do. Okay, thank you very much.